I'd like to introduce Rémi,
Yeah.
the developer of Provider, Flutter hooks, functional widget. The list goes on. So, like, really, you know, we have a superstar amongst us.
Hello, everyone. Yeah. So today, I want to talk about something slightly different than what I usually do. I will talk about me reinventing Provider recently. So before you start panicking and trying to wonder if you have to migrate everything, you don't. It's mostly at the experimental stage. And I just want to share it with you to get some feedback with the community and see if it's something that is actually that you are actually interested in. So the code name of this project is RiverPod. If you're wondering why RiverPod, it's basically just because it's an anagram of provider, so I find it funny. It's not very funny, but whatever. So the way it will go is the first step of this talk will be to go through the history of state management in a way to see the different problems that provider tries to solve. And then we'll go through what that experimental project does. So the very first problem a provider tries to solve is usually it's commonly known that globals and singletons are not necessarily a good thing for large-scale applications. There are multiple reasons that you can find on different articles online, but the short story is one of the reasons is globals and singletons can be accessed everywhere and modified everywhere too. So what that means is as the application grows, you have more and more of these global variables, and you have more things that modify these variables. But since it's done without any restriction, it's very difficult to keep track of the flow of the application. So the application is learning how to learning the code base as the application grows becomes incredibly difficult. And the second point is they make testing more difficult. By that I mean, for example, if you have multiple tests, you might find yourself in a situation where, for example, in this snippet, if you run the second test first and then the first test, both will pass. But if you run the first test first and then the second test will fail, because they depend on some common variables, but these variables are not reset when a test is finished. So one way to fix this kind of problem would be to use setup and teardowns inside your tests. But even then, it's still not ideal as the application grows, you will have more and more of these variables. And so you will need to add more and more stuff to the setup and teardowns. And it's also something that you have to think about. It's not done naturally. So you could find yourself with silent errors and have bugs in your code without noticing it. So you may have bugs and your test not detecting them early enough. So a solution for this that the community found is to use inherited widgets for this kind of thing. There are two main reasons for it. One of them is inherited widgets as their widgets benefits from something called unidirectional data flow, which is a way of restricting the flow of the application voluntarily to make things more scalable. And secondly, the widget it makes that the widget tree two different tests don't share state, and And the way it's typically used is that instead of declaring a global variable, we add a new widget inside our widget tree that contains this variable and expose it to the widget tree. So the consequence is on our tests, instead of having a global variable, then both of our tests will use that provider widget. But the thing is, both tests will use a unique instance of the objects that you want to expose. So both tests don't share state, and therefore you don't need to do these setup and teardowns. So you remove the complexity here. And there are also side benefits to using inherited widgets. For example, it allows listening to objects in a one-liner. So you don't need these builders to do the listening. So you get some increased readability here because you get more focus on what matters instead of having this huge boilerplate. Then, sorry. There are DevTool compatibles. Since there are widgets, they are in the widget tree. And therefore, when you inspect the widget tree, you are able to inspect the state of your inherited widgets. So here we see a screenshot of what happens when you use provider. And you can see the state of your change identifier provider. You also get increased reusability of your widgets because the widgets that are using these global states are decoupled from the variable itself, which means you can potentially override these global variables for a specific part of the application. One use case would be, for example, to have a tutorial screen kind of like this, where typically in a normal application, you would do the tutorial screen with a screenshot. But another way of doing it would be to reuse the My App widget, but with different providers, mocked such that there is no HTTP request involved. This way you get this same behavior as a screenshot, but dynamic. So you could make it internationalized or animated, for example, which may be very powerful. So that's very cool. But inherited widgets are not without issues. For example, they introduce runtime exceptions. By that, I mean that when you call the method to obtain the inherited widget, be it scope_model.auth or provider.auth, there is the possibility that the object you're trying to access is not located, is not inside the widget tree, so you cannot access it. Or the build context that you are using is not able to read the provider, such as, for example, if it was in a different widget, in a different branch of the widget tree. So one of the issues with this is it's pretty confusing for a big part of the Flutter community, as the build context object is not necessarily natural, and therefore many people are getting these runtime exceptions and don't understand why. And scope_model tried to solve this with a widget called scope_model_descendant, or if you're using provider, it's called consumer. But even then, it still doesn't really fix the problem, and we get the we don't have the one-liner anymore. Yeah, another problem that I like to name it the nesting L, where as the application grows, you have more and more of these providers. So what looks readable in the beginning starts to become more like this, where you have tons of nested inherited widgets, which is not very readable. And a third problem is the build method of a widget has to be what we call pure. By that I mean the build method or the builder parameter of the widget can be called many times, and it can be called at any time. You should not prevent the build method from being called, but that's something that people don't necessarily realize. And what it implies is that you should not perform HTTP requests or create state inside the build method and builder. Otherwise, you could potentially lose the state of your application when you go to a new screen or open the keyboard. And many people got stuck on this problem. Finally, there is too much disparity between packages because, at least at the time, because say if you're using block provider from 2 years ago, there was a library called block provider from DJ Boulens. If you're using the inherited widgets from block provider, and you cannot use that block provider with the scope model descendant widget from scope model, you cannot combine them because both of them use different inherited widgets internally and they are not compatible with each other. So we kind of end up in a situation where we have to reinvent these utilities for all the different libraries using inherited widgets. So this causes some confusion in the community where something that is inside a library but not inside another one, and everybody tries to solve the same problems but differently. It's not very, very good. Yeah. And so that's why provider was introduced. The main reason why it was introduced was to first try and fix this disparity issue by introducing a new standard that everybody uses. So I wanted to make inherited widget that works for pretty much all use case, such that the utilities can be reused for everyone. Then we want to solve the nesting problem by introducing a multi-provider widget, which makes the widget really linear and therefore more readable. Similarly, it solves the build method is pure problem by changing slightly the way inherited widgets are used. So we are going from creating the object directly as inside the parameter to passing a function that creates the parameter. This way, the function is executed only once, even if the widget rebuilds. So therefore, we are guaranteed to not lose the state. And it's more natural in this way. So provider did a pretty good job at solving this problem, at least in my opinion. It's widely accepted by the community now. So that's great. But it's still not perfect. The runtime exceptions that I mentioned previously is still an issue. And it's not as flexible as it should be. Like, for example, many people have requested stream proxy provider, but it's not necessarily possible to do. Or there are limitations like you can't have two providers using the same type, or people also want to dispose the state of a provider when the provider is not used anymore, but still in the widget tree. And finally, another problem is people don't necessarily like that it depends on Flutter, and they think they want to extract this logic of exposing widgets, exposing state, outside of Flutter to kind of separate the logic between UI and business logic. Yeah. So these problems can't be fixed as part of provider, at least not in a way that wouldn't break everyone's code. So that's not very reasonable. And the main reason for this is because these problems are deeply rooted in how provider or inherited widgets in general works. this will require a very low-level change to be fixed. So that's why the project RiverPods that I mentioned previously is all about. Like I mentioned, it's very experimental. It's absolutely not made to replace provider, at least not in the short term. It's more testing the possibilities and seeing if it's truly a solution. And then if it is, maybe it may replace provider, but at least not in the short term. So to explain more about the project and how it works, I think a good way to do so would be to start with a simple hello world. So what we will do is create a state that contains a simple hello world string, and then we will try to read it. So first, to create this state, what we would do is create a provider. So creating a provider using RiverPod is by creating a global constant. So it's this line here. You use the provider class, and then you specify a callback that returns this state you want to create. So here, a simple hello world string. And then you give it whatever name you want. So here, greeting provider. And then the other step is inside your main, you need to wrap your application in a new widget called provider scope. It's kind of similar to multi-provider, but it doesn't take the providers as parameter. You don't need to pass anything to it. Then finally, to consume the value, you have multiple solutions. The first one is to use the Flutter hooks library that I made too. So using Flutter hooks, we could use a hook widget and not a stateless widget, a hook widget, and then use the use provider function. So using that use provider function, what we will do is we would pass to the use provider the providers that we want to consume. So here, greeting provider. And then that function will return the current value exposed by the provider. And then we can use that value to do to build our widget tree. Another solution would be to use a stateless widget, like we would do in typical Flutter, and instead use a consumer widget. So it's slightly more verbose, but it doesn't depend on further hooks. And the principle is slightly similar in that that consumer widget takes the provider that you want to consume as parameter. And then it takes a secondary parameter that is a builder callback, which receives the value consumed as parameter, and then builds a widget out of it. So one thing you may have noticed is that providers are no longer obtained by type. Instead, they are obtained by reference on the provider, which has an interesting consequence, which is that it's compile safe, in the sense that you don't, if you are able to write the line use provider, my provider, then you are guaranteed to be able to obtain the state of the provider, because when doing so, this will automatically create the this will automatically insert the state higher in the hierarchy, like you would typically do in provider. So you don't get this runtime exception anymore by doing so, which is great. A second point would be, since we are not using types anymore, that means we can have as many providers of the same type as we want. So for example, we could split it into 2 different providers, such that, for example, we could split the hello world into an interjection and a noun. So, and then we could consume them independently similarly. So use provider, interjection provider, use noun, use provider, my noun. And finally, since we are reading them by variables once again, then we could technically make the variable private or limited to a specific file. So it allows more freedom on who can access the provider. But then you may be wondering that at the beginning of the talk, I mentioned that global variables are not necessarily scalable. So why am I making global variables once again? But the thing is, this is not exactly global variables. Because while our provider is declared globally, the state of the provider is not stored inside the provider. In fact, the state of the provider is stored inside that provider scope widget, which means that first, it's DevTool friendly because it's stored inside a widget, so you will be able to inspect the state inside your DevTool. But more importantly, when you're writing tests, we get the same benefits once again of if you have two tests, both of them will point to a different instance of the widget tree. So there still won't be shared state between the tests. So you won't have the issues mentioned previously. Similarly, it re-implements the same logics as with inherited widgets. So you could still re-implement the mechanism of overriding the state for a specific widget tree by adding the provider scope widget at a specific location where we want to override the provider, and then add extra arguments to the provider, to the widget. So here, the parameter would be overrides, which takes a list of override. And an override would be created by taking the provider that we want to override, and then we call a function on that provider that is override for subtree. The name may change, but that's the basic idea. And to that function, we pass the new behavior of the provider. So here it says Bonjour Paris, which is hello Paris in French, which means that now our tutorial screen will receive Bonjour Paris, but the rest of the application will receive hello world. So we get the same behavior as we mentioned previously. It's also worth noting that this project actually doesn't depend on Flutter to work. It's split into 3 different packages. The first of them is RiverPod, which contains the different providers, so provider, feature provider, whatever. Then there is Flutter RiverPod, which exposes the provider scope, consumer, and Hooks RiverPod, which expose the use provider function. So onto a slightly more complex example to showcase combining providers. One use case would be to have a configuration file that is loaded from, that is a JSON file. And then we want to instantiate a configuration object from that JSON file. Then we want to have a repository that is depending on the configurations to obtain maybe an API key or the host or whatever. And then we want to create a model that will interact with this repository object and expose maybe stuff that the UI can use. And that model would depend on the repository. So to do this, here's the entire code. The first step would be to create the configuration provider. So here, what we will use is future provider because we want to load our configurations asynchronously. So we would want to use the async await keywords, which future provider allows you to do. And then inside the callback of the future provider, we will read the file decode it, and then create an instance of the object from the decoded JSON. So that's it for the configuration. So the next step would be to create the repository. So for the repository, we will simply use a simple provider. But the twist is we want to consume the configurations. So for this, we will need the parameter passed to the callback of provider. And that parameter is called provider reference. This is kind of similar to the build context in Flutter, but is not related to Flutter. And it allows you to read providers. So in that case, here, what we will do is we will pass this provider reference object to the repository. And it's safe to do so once again, because this object doesn't depend on Flutter at all. It's not UI related. So it's safe. And then what we could do to obtain the configurations is use that reference object and then call the method dependOn. And so what we would do is call dependOn and then pass the parameters that we want to consume. And here, since configuration providers is a future provider, then it's loaded asynchronously. So dependOn will return the future that you need to await to obtain the configurations. So the repository here will await the future to obtain the configurations and do something with it. So once again, we have this type safety of the thing. We are guaranteeing that there is no situation in which we're trying to read the provider, but the provider is not actually ready yet. And then the final part would be to create the model. So to create the model, we can use change notifier provider. You don't have to use change notifier, it's just for the sake of the example. It's the most popular alternative, I think. So here, we could do things slightly differently than before. And instead of passing the provider reference to the model instance, we could read the provider directly inside the callback. Using the same pattern as before, using ref.dependOnMyProvider. And here it's worth noting that since it's not a future provider, but just a simple provider, then dependOn doesn't return a future anymore. Instead, it returns the value directly. So you can just do dependOn and access the value without having to await anything in particular. And then we pass that repository to our model object. And the model object itself is just a simple state notifier, a simple change notifier without anything in particular. So we can just skip it. Yeah. So there are some extra features that I won't necessarily cover here, as we don't necessarily have the time, but it's worth noting that Riverpod also includes features such as automatically disposing the provider when it's no longer used, but still in the repository, like we mentioned previously, that was requested. It's also more flexible on combining providers. It exposes many different providers like state notifier provider, stream provider. And it also exposes these features similar to what you would find in the provider package for filtering rebuilds, such as selector. Yeah. So as a rapid conclusion, Riverpod is an experimental rewrite of provider. It's not production ready. It's merely an attempt to solve some problems, but I don't want to push it for now as a replacement for provider. It may come in the future, but it's not necessarily sure. And what it tries to solve is basically doing exactly the same thing as provider, but in a slightly different syntax, such that it doesn't have dependency on Flutter. and it's compile safe and more flexible for the commonly requested features. So that's the basic idea of the project. And I think that's about it. So yeah, thank you.
Great talk. Thank you very much.